Hello everyone, hope you guys are doing well today. We're going to be working through 4 of these problems. This video is going to take quite some time, so make sure you get yourself a cup of coffee, hot cocoa, milk, whatever you need, whatever snacks that you need to sustain your attention span as we go through 4 problems. Okay? What we're going to be doing is we're going to be looking at each problem, trying to figure out how the easiest and best way to solve it for you. So make sure you're ready to go, have some graph paper and jot things down as I'm working through. So here we go. We have a pendulum, and it's swinging back and forth. After t seconds, the horizontal distance from the bob to the place where it was released is given by this equation right here. It says, how often does the bob cross its midline? Give an exact answer, so after so many seconds. So the first thing we were going to do, we're dealing with a cosine graph, so I'm going to rearrange some things. So I'm going to say h of t equals, now I'm going to go ahead and start out with this -7 cosine. -7 cosine, all right? And I am going to go ahead and distribute the 2 pi to the t, get 2 pi times t, and 2 pi times -2 is -4 pi, all over 20, and then that 7 I'm going to put in the back. All right, and I'm just going to look at our a value, our b value, our c value, and our d value. Okay, so our a value is going to be -7. All right, our b value is this portion right here. It's 2 pi divided by 20. Now 2 pi divided by 20 gets us what's called pi over 10. So technically the b value is pi over 10. The next thing I'm going to do is I'm going to take this value and divide it by 20. And that's going to give us our c value. So -4 pi divided, sorry, not -4 pi, 4 pi divided by 20 is going to be pi over 5. So our c value is going to be pi over 5. Now, I'm just going over real quick. I'm using this formula, a cosine, b, I'm going to put x instead of theta, minus c plus d. So I'm going from this basic formula right here. Okay? And the last thing, our d value is our midline. That is the number 7. That's the number 7. All right? So, it's going to be important when we're doing this problem. First of all, we're going to rewrite it in a different form and show you guys that these 2 forms that we're about to write are the exact same equation. So we have h of t equals -7 cosine. I'm just going to rewrite it as pi over 10 t minus pi over 5 plus 7. All right? What I'm wanting to tell you is this and this are exactly the same. Now this is a little bit easier to interpret some things. Right here, this part right in here, I'm going to highlight it in orange. That lets us know we have a phase shift right there. Now that phase shift is basically 2 units. So when you factor everything out, it makes it nice and easy. I'm going to put, we have a phase shift that's equal to 2 units. All right? Now, there's 2 formulas that you need. First of all, you need to know the difference between finding the length of the period of the function and also dealing with phase shift. So I want to show you how both of those work. The period will always be 2 pi divided by b. And 2 pi divided by b in this particular case is going to be 2 pi divided by pi over 10. Alright, and to get rid of this pesky pi over 10 in the denominator, we multiply it by its reciprocal, which is 10 over pi and 10 over pi. All of these cancel out. Those 10s cancel out. Those pi's cancel out. And these pi's will cancel out, and we're left with 2 times 10, which is 20. So the length of our period is 20 units. And those 20 units are going to help us with this particular problem, and I'll tell you why in just a few moments. Next thing I want to show you guys is how to find the phase shift real quick. Once again, the phase shift will always be the c value divided by the b value. Our c value is pi divided by 5. Our b value is pi divided by 10. Now I already told you the phase shift was 2 units, but I want you to see how you could also check your logic here. All right. Multiply that by 10 over pi, multiply that by 10 over pi, these pi's cancel out, these 10's cancel out, those pi's cancel out, and 10 divided by 5 is 2. So we have a phase shift of 2, and we have a period of 20. So right now, all I'm going to do is I'm going to sketch this graph real quick. I'm just doing all this by hand. Now, I'm going to show you guys how to do it in Desmos so you can kind of check your work. So this is my midline, all right? If it's -7, all right, if you have a negative cosine graph, it's going to start down here. It's going to work its way up to the midline. It's going to cross over the midline, come back down to the midline, and then finish up right there. All right? And now all I'm going to do is I'm going to break it into some sections. So here we go. We have that section right there, this section. So we'll break it down into its parts, and hopefully you can see that each of these represent a quarter of the cosine graph. All right, and so right here, it's going to hit the midline here, and it's going to hit the midline here. Now the trick to this problem, without having to do a whole ton of work, all right, is to understand that a negative cosine of x graph is going to look like this, no matter what the amplitude is. So even though the a value is -7, which means the amplitude is 7, it's still going to look like this. And it says, right now, how often does the bob cross its midline? Well, it crosses it right here, and it crosses it right here, which means if the whole length of the period right there, if the length of the period is 20 units, and that's the whole way there, well, what's a quarter and a quarter? A quarter is half. So this distance right here is 10 units. In this particular case, these units mean seconds. Okay, so every 10 seconds, it's going to hit the midline. Okay, now I'm going to go over here, and I typed in the Desmos. I typed in our function right here. All right. And I also want to let you guys know that the other function that we converted it to, -7 cosine, all right, and that was, I believe, pi divided by 10, divided x minus pi divided by 5, and then we had +7 here. All right, I wanted you to see that those are the same. It's a good way if you're kind of figuring things out, you want to make sure you can use Desmos to check it. And you can kind of see, I'm going to go delete that now. You can see on this graph that right here it crosses it at 7,7 and it crosses it at 17,7. Well, what's the gap between a 7 and a 17? The gap is 10. So it kind of lets us know between each midline it's going up 10 seconds. So that's another way of interpreting it. All right. So we go back over here, type in 10. And voila. All right. So that's question number 1. We're going to be working on this next question. All right. So get ready to go. And in this next question, it says the day length in Juneau, Alaska varies over a time in a periodic way that can be modeled by a trigonometric function. Assume the length of the year, which is the period of change, is exactly 365. That's going to be important information. Hold on. Screenshot real quick. Alright, so one thing I want you to write down is we do have a period of 365 days. That is going to be the length of our period. Okay? The longest day of the year is June 22nd, and the longest day is 1,096.5 minutes long. So that kind of gives us our maximum. So right now I'm going to put our maximum is equal to 1,096.5 minutes. And then it says the shortest day of the year. So the shortest day is going to be at 382.5 minutes. So that's going to be our minimum. All right, and that ends up being a half of a year later. So our minimum is going to be at 382.5. All right, and then the last piece of information that's going to be helpful for us is this piece right in here. It says June 21st is 171 days after January 1st. Now that's going to help us with our phase shift. All right, so we're actually going to make a cosine function, and our phase shift is going to be 171 days. 171. All right. So what we're going to do is we are going to build a cosine function. It's going to be L of t, so let's put L of t. We are going to find the amplitude. The reason why we're doing a cosine function is a cosine function starts, if you look at it, it starts with the maximum, goes down to its minimum, and then it goes right back up to its maximum. Okay, so that's why we're doing a cosine of theta, or cosine of x. All right, so that's why we're choosing cosine versus sine. All right, just remember the sine function looks more like this. It goes up and down and back up. All right. Now the midline for a cosine function goes straight through the middle here, whereas the sine function, the midline, is right there. It starts at the midline. Here it starts above it. Here it starts at it. So we're using cosine versus sine. All right. That's sine of x. All right. So we have a cosine. Then we have bx minus c plus d. Now, the first thing I like to do when I'm solving these problems is basically just find the midline and find the amplitude. So the a value is the absolute value of the amplitude. Sorry, the absolute value of the a value is the amplitude. Right, and our d value is our midline. So that's what we're going to be finding first. All right. So first thing we're going to do is we're going to find our amplitude. All we got to do is find the gap between, find this gap, we'll put G, A, P. Find the difference between 1096.5 and 382.5. Find that gap. Subtract those. You'll get a total of 714. That's the gap between those two numbers if you subtract them. All right, then we're going to take that gap and we are going to divide it by 2 to find our amplitude. So our amplitude will equal 714 divided by 2, which becomes 357. Now we're dealing with a positive cosine graph, so our a value is actually just going to remain 357. All right, that's going to be our amplitude, right? Also our a value. All right, next thing we're going to do is we're going to take a look at our midline. To find our midline, I'm just going to put MID. What we're going to do is we're going to take 1096.5. We're going to take our maximum. We are going to add our minimum. All right, we're going to add them together, and then we're going to take half of it. All right, so when you do that, when you add these together, you get 1,479, and when you divide that by 2, you get 739.5. So right over here, I'm going to write 739.5. 739.5. So now we're almost done. All we've got to find is our B and our C value, and we will write everything in. I'm going to try to find a little bit easier way for you guys to figure this out. So just remember, the period will always equal 2 pi divided by B. So if the period is always equal to 2 pi divided by B, and the period, they've given us the period, which is 365 over 1. Right now, we'll go ahead and take those cross products. And you get 365b equals 2 pi. So we divide both sides by 365. So our b value ends up becoming 2 pi over 365. 2 pi over 365. kind of complicated, but I'll go ahead and write it down. 2 pi over 365. Next, and the last thing we're going to talk about is our phase shift. Now, they've given us our phase shift. They said our phase shift was 171. Now, just remember, C divided by B is always equal to our phase shift. So I'm going to write phase shift. This is the formula for your phase shift. We've talked about it earlier. Not in this video, but earlier in class. All right, so C divided by B is our phase shift, and so our phase shift is equal to 171 over 1. I don't know my C value, but I do know my B value. My B value is 2 pi over 365. This is kind of funny. So I'm going to show you guys how we create our formula or equation out of this. All right, so our C value equals 2 pi over 365 times 171. And I'm not going to multiply those together. I'm just going to leave it sitting right here. All right, so I want you to understand, I want you to see something that is the B value and the C value have in common. Hopefully you'll see the B value and the C value have something in common. They have 2 pi over 365, except we have a 171. So right now, this is the most important part of this whole video, is once you have all of this information, how can you take it and put it in to the final answer? So watch how I do it and see if this makes sense to you. Hopefully it does. My A value is 357, so I'm going to put 357. Okay? Now, my B value is 2 pi over 365. All right, so I'm going to put 2 pi over 365 minus, my C value is 2 pi times 171. Oh, I forgot to put an X right here. Sorry, my apologies. Put an X right there. Actually, it's not going to be X. It's going to be T. So I'll put the letter T. See if I can make it a little bit neater here. There we go. Let's put the letter T right here. Then I'll put minus 2 pi times 171 all over 365. Close it. And then I'm going to add the midline, which is 739.5. Now I want you to see how these have common factors. They are both being multiplied by 2 pi over 365. So here's how I would write my final answer. This is going to hopefully make a lot more sense once I get this done. You can kind of see how the final answer is created, and then you'll know what to do if you get one that's similar to this on your own. All right? So what I'm going to do is I am going to create a little fraction right here, and I'm going to put 365 in the denominator because they both have 365 in the denominator. I'm going to put 2 pi right here. I'm going to open up a parentheses. I'm going to factor out a 2 pi out of this and a 2 pi out of this. All right? And you're left with T, there's the T value, all right, 1T minus 171. Close the parentheses, and then you put plus 739.5. And that is going to be your final answer. Now, this is important right here, the whole phase shift. Right? You guys see this phase shift right here? Remember when I said the phase shift was 171? If we go back to our previous problem, what was our phase shift here? T minus 2. So if you look at the previous problem and how they set it up, it's going to help you build your function when it's time to build your function. So I want you to see what I did here. Here the phase shift was 2. See how it's 2 pi over 20? All right, and interestingly enough, what was the length of the period in this problem? The length of the period was 20. Over here, what's the length of the period in this problem? The length of the period in this problem was 365. So it kind of gives you some clues of how to do it on your own. So right now I'm going to go ahead and type it in. All right, here we go. We got 357. All right, we'll type in cosine. open up a parentheses, make a little fraction. All right, type in a 2 pi, open that parentheses, put t minus 171 all over 365, and right here on the outside put plus 739.5. And before I do anything, I want to make sure I wrote everything nice and neat. Let me check my work. Oh, hold on. Maybe I messed up. No, 357. I think I said 375. There's 357. All right. Having some work done in our house today. Cosine 2 pi t minus 171 over 365 plus 739.5. I know. I'm kind of obsessing, making sure I got everything nice and right. Hit check. Hey, we got it right because we took our time. All right, see what the next question is. Actually, you know what? I'm going to go ahead and stop this video, and I will do another video dealing with the next two questions. Y'all have a good day.